our channel. So in this today's session, let us have a look on digital signature algorithm. So far we have seen different algorithms, that is a cryptographic algorithms which provides the security, and then authentication algorithms which provides the authentication, and key exchange algorithms where we have to exchange the secret key among the sender and receiver. Now in this session, let's have a look on one more security service, that is digital signature algorithm. So before going to the algorithm, first we have to know what is a digital signature. So as we know that in the asymmetric encryption, so we will be having two different keys. One is a public key and another one is a private key, where the public key is available for all the users and the private key will be not shareable, only it will be with a particular person, right? So if the message is encrypted using sender private key, so this is very important. So if the message or hash code or anything, if the encryption is done using the sender's private key, then automatically we call it as a digital signature. So here the private key is not shareable, so only the user or a sender can only send the message, because the sender will not share their private key with any other user, so the message can be encrypted only by the sender. So that's why we call this process as a digital signature, right? So once again I'm repeating, if the encryption, so here obviously the encryption will be done at the sender side and the decryption will be done at the receiver side. So if the encryption is done by using sender's private key, then automatically we can say this process as a digital signature. See, let us see that. So consider the plain text message. Plain text message. So apply the hash functions so that we will get hash code. So this is a hash code which is appended with the plain text message. Which is encrypted by using private key of A. Here if it is A and if it is B here, then the message will be in this form. This is the hash code. So this is the encrypted message, and at the receiver side it is first decrypted by using public key of A, which is available with all the users, so that we will get again the plain text message and hash code, where again hash functions are applied so that we will get some hash code, and this appended hash code will be compared. So if the message has been sent like this, we can say it as a digital signature, because at the sender side we are using the private key. So here in this digital signature approach, there are two approaches for this digital signatures. One is RSA approach, another one is DSS approach. So this we can call it as a DSS or DSA or DSA. So DSS is a digital signature standard. Digital signature standard algorithm, or we can simply say it as DSA, that is digital signature algorithm. So anything is same, right? So one is a RSA approach, another one is a DSS approach. So first let us see this RSA approach, then we will move on to this DSA approach. See, first, digital signature using RSA approach. Digital signature using RSA approach. So, consider the plain text message. Consider the plain text message. So, which is applied to the hash function, so that we will get some hash code, and apply the encryption. That means that particular hash code will be encrypted by using public key of A, which is appended with this plain text message. Sorry. So that we will get plain text message, and this is the encrypted hash code by using PUA. So this representation is hash code which is encrypted by using public key of A. So this will be sent to the receiver. So receiver will receive this one, again applies the hash function, and alright, so apply the hash functions, so that hash code will be generated, and this one will be decrypted by using so this is digital signature. We have to use a private key of A, right? So it is a digital signature, so we have to use the sender's private key. So here we are using the private key of sender, so here we have to decrypt it with public key of sender. Public key of sender, so that here hash code will become, and both hash codes will be compared. So this is the simple approach for a digital signature, for achieving the digital signature using this RSA approach. Here we are using RSA approach, and here we have to use hash. Hash means SHA-512 or SHA-1 algorithm. Here in this encryption we are using RSA algorithm, right? So this is the encryption. So here we are using the RSA algorithm, and here we are using for hash functions. That means for generating this hash code we are using SHA-512 or SHA-1, which we have already completed in the previous session, right? So this is the simple RSA approach. Next we will move on to the second approach, that is digital signature standard algorithm. DSS approach. DSS approach, or we can simply say it as DSA approach. First, consider the plain text message, apply the hash function, and then hash code will be generated, and for this hash code input one more variable that is called K. Here K is not a secret key, it is a random number. It is a random number, and this will be given to signature algorithm. This will be given as inputs to signature algorithm, and for this signature we will use PUG, that is a public key, global public key. Along with this we will use private key of sender, that is PIA, and so that we will get the signature, and both signature and the plain text will be appended, so that we will get this is the plain text, and two components will be received. One is S, another one is R. So what are these components, S and R? So here the signature elements or signature components are S comma R. This is called a signature. So both S and R will give the signature. And at the receiver side, again the reverse process will be done. So first hash functions will be applied, and along with these hash functions, these three also will be given to the verifying function. So for this, again we will use public key of global elements. Along with the global elements, we will use a public key of A, so that we will get the resultant, and this resultant and this R will be compared. Right? So instead of writing this public key, we can use it as a global public elements. Global public elements. Right? So this is the process done in DSS approach, digital signature using DSS approach. So here once again let us repeat. So first consider the plain text message and then apply the hash functions. Again here also we have to use a SHA algorithm, either SHA-1 or SHA-512. So we have to use a SHA algorithm H, so that we will get the hash code which is given as input to the signature algorithm, as well as a K. K is a random number which is given as input for the signature algorithm. Here we will use two components here. One is G. G for global parameters or global components. Global elements, we can call anything. Global elements. And PRA. PRA is private key of user A. And signature is S comma R, and verification algorithm. So at the sender side signature algorithm will be happened, at the receiver side verification algorithm will be happened. So in the verification algorithm also we will use the signature components along with the global components, and here we are using the private key, so here we have to use the public key. So here public key will be used, so that the resultant and the R will be compared. Here R is a signature, major signature component. So R should be compared with the resultant, calculated value. Right? So hope you understood this DSS approach. So let us see the algorithm. So how these will be calculated, what are the formula for these calculations, what is the G and what is the S and what is R and what is the V. So here V will be generated. So what is a V, right? So let us see the formulas. See, now this is digital signature standard or digital signature algorithm, anything. So for this digital signature algorithm, first we have to get the global public key components. So global public key components. So what are the global public key components? First one is P. As we know, P is a prime number. So we have to consider this prime number where P must be in between 2 power L minus 1 less than P less than 2 power L. P lies in between 2 power L minus 1 and L. L is the length of bits, which is multiple of 64. Next, Q. Here Q is a prime divisor of p minus 1. Prime divisor of p minus 1. So here we can say, just I will give an example. Let us consider p as a 11. So as it is a prime number, so q must be prime divisor of 10, p minus 1. So 5 is a prime divisor of 10. So 5 will be the q value. So hope you understood this, right? So here the q is a prime divisor of p minus 1. Next, excuse me. So here we have both are the primes, right? P is a prime and Q is also a prime. It's a prime divisor. Next, G value. G is a global component. Here G is a global component, which is H power P minus 1 divided by Q mod P. So this is the G value. So here H power, H is any integer. H is not a hash code. Here H is any integer which lies in between 1 and p minus 1. H is any integer which lies in between 1 and p minus 1. So these all are called public key components. So after considering these public key components, and these public key components will be used at both the sender side and receiver side, as we have seen in the previous diagram, right? So after getting all these things, now we have to select the private key of user A. User private key, which we call it as X. X. So X can be any random number. So X can be a private key which is any random number in between 0 and Q. 0 and Q. User's private key. Next, based upon the private key, we have to calculate the public key. So user public key. So user's public key, we call it as Y. Y is equal to G power X mod Q. Sorry, G power X mod P. It is a user's public key. So this is the user's public key. So global public key components P, Q and G, and then we have to select the private key of user A, so which is a random number, and from this random number we have to select the public key. We have to calculate the private key. We have to calculate the public key. So here the private key is X and public key is Y. So Y is calculated by using this private key. So Y is equal to G power X. Here G is a global public component. So G power X, which is a private key, mod P. P is a prime number. Right? Now, so after that we have to select K. K is any integer. K is also any integer which lies in between 0 and Q. It's a secret number. It is a secret number. Next, so after getting all these things, we should get the signature algorithm R and S components, right? So next, signature component. So here signature component is G power K mod P mod Q, right? So G power mod P mod Q, which is R. So we have to calculate one more component, that is S. S is equal to, right? S is equal to K inverse. K is a secret key, so K inverse H of M. H of M is hash functions applied on the plain text message plus X into R. As we know, X is a private key and R is a one more signature component. So mod Q. So this is the signature function. This is the signature function. So which must be applied on the sender side. Now the message will be sent to the receiver. Now the receiver will receive, and again they will apply some more functions and they will compare this signature component R with V. So here in the decryption we have to sorry, not in the decryption. So at the receiver side V will be calculated and that V and R will be compared. Now verifying function. Verifying function. So for this verifying function we will get a V value. So V is equal to G power U1, right, where G is a public key component, Y power U2, and Y is a public key. Mod P mod Q. Right? G power U1, Y power U2, mod P, mod Q. Now we have to calculate this U1 and U2. So U1 is equal to hash functions applied on M dash W, hash functions applied on M dash. So here M dash is a message which has been received by the sender. So at the sender side we will call it as M, and at the receiver side whatever the message we are receiving, that we call it as M dash. So M dash into W mod Q. So U1 is equal to H of M dash, that is hash functions applied on received message into W. So what is the W now? So W is equal to S dash inverse mod Q. What is S dash? So S is the signature component which is received by the receiver. So S is generated at the sender side, and whatever the component received by the receiver is called S dash. So S dash inverse mod Q will be W value. And U2 value. U2 is equal to R dash into W mod Q. R dash into W mod Q. So this is the formula. So here R dash is a signature component which is received at the receiver side. So here M dash, R dash, S dash are at the receiver side. The message and signature components which are received at the receiver. And this V and R. So R here, R means R dash. So V and R dash will be compared. So what is the comparison? V is equal to R dash. This will be compared. So R dash is received component and V is calculated at the receiver. So this is calculated at the receiver side. So hope you understood. So once again I will repeat it. So this is a digital signature algorithm. So there are two approaches. So one thing is, if the encryption uses the private key of sender, then we can say it as a digital signature. That is the first thing. Second thing, so here there are two approaches to achieve the digital signature. One is RSA approach, another one is DSS approach. So coming to this RSA approach, previously we have seen first the hash functions will be applied on the plain text message so that we will get the hash code, and we will encrypt that particular hash code, not a message, only the hash code. We are encrypting the hash code by using the sender's private key and appended with the plain text message and sending to the receiver. So receiver receive the message, and again the receiver will apply the same hash functions on the plain text message, and again the hash code will be generated, and the encrypted hash code will be decrypted by using the public key of user A, and both will be compared. So that is the RSA approach. Coming to the second approach, that is a digital signature approach. Here at the sender side we will use the signature algorithm, and at the receiver side we will use the verification algorithm. So here also we will use at the sender side we will use the private key, and at the receiver side we will use the public key. So apart from this, we will use some more public key components like P, Q and G. So here P is a prime number which lies in between 2 power L minus 1 and L, 2 power L. So here L is the length of the bits, which is a multiple of 64. Next, Q is a prime divisor of P minus 1. So here you have to observe it is a P minus 1. So if it is a prime divisor of P, here P is also a prime. There will be no divisor, right? So Q is a prime divisor of P minus 1. And G is a global component which is used at both the sender and receiver side. So all these three components will be used both at sender and receiver side. So G is a combination of both P and Q. So G is equal to H power P minus 1 divided by Q mod P. So here H is not a hash code. H is an integer value which lies in between 1 and P minus 1. Any integer value, right? So this is also very important. H is not a hash code. H is any integer. H is any integer which lies in between 1 and P minus 1. So after getting all these public key components, we have to select the user's private key, which is a random number generator. By using the random number generator, we can select any number which is private key, which acts as a private key. So here the number should lies in between 0 and Q. So after selecting this private key, we have to compute the public key. So here the public key is Y, which is equal to G power X. Here G is a global key component. G power X, X is the private key, mod P. So after completion of this, we have to select one integer, secret integer. Here K is not a key, it is a integer. This is also very important, right? So here K is any integer, so which lies in between 0 and Q. So at the sender side, so after getting all these things, now we have to perform the signature at the sender side, and at the receiver side we have to perform this verification algorithm. So at the signature algorithm we will get two components, signature components called R and S. So here R is equal to G power K. Here G is a global public key component, power K. K is a integer, secret number. So we can call it as a secret number. So K is a secret number, mod P, mod Q. So we will get a value for R, and S. S is equal to K inverse. K is secret key, inverse H of M, which is nothing but a hash code. Hash code plus X is a private key, and R is one of the signature component, mod Q. So for this we will get the two components R and S. So this R and S will be sent to the receiver side. So first these two R and S components, that means signature components, will be appended with the plain text message and then it will be sent to the receiver. So immediately, see here, I am writing here, sender side we will send M or S. At the receiver side, the components will be the notation of these components will be changed to M dash, R dash, S dash. So this is the receiver side, this is the sender side. Now in the verification side, that means that we are calculating at the receiver side. So in the verification we have to calculate the V, and which is compared with the received version of R dash. So V is equal to G power U1 Y power U2 mod P mod Q. So here we have to know about U1 and U2 components. So U1 is calculated by using received message. That means again we have to apply the hash functions on the received message so that we will get the hash code. Product with W mod Q. Here again we have to get this W. So how to get this W? W is equal to S1, that is received signature component, S1 or S dash inverse mod Q. So from this we will get a U1 and then U2. U2 is equal to R dash. R is also received signature component. R dash into W. W is again the signature component mod Q. So that U2 will be getting. So V will be calculated and this V and received R dash will be compared. So this is the digital signature algorithm. Digital signature, or we can call it as a digital signature standard algorithm, DSS or DSA. So hope you understood this DSA algorithm. So if you are having any doubts regarding this DSA algorithm, feel free to post your doubts in the comment section so that I will definitely try to clarify all your doubts. And if you really understood my videos, like my videos and share my videos with your friends, and don't forget to subscribe to our channel. And thanks for watching. Thank you very much.